Hey everybody! Today we're gonna finish up our unit. Yeah, that's awesome. We're right on track for where I kind of want to be. If we finish up Unit 8 here, obviously we only have 1 week left in the quarter, so that's super. Almost get the fours out. Fourth quarter coming, and we're gonna finish up Unit 8, get into Unit 9, be able to finish that hopefully before the air test. And then I think you guys will be pretty well prepared. I'll be happy with where you're at least. So then we can hopefully have a little bit of time to review all the huge amounts of information we've learned this year, which is a lot. So today we're going to compare linear functions, exponential functions, and quadratic functions. And in particular, let's say I'm looking at a table of values. So let's say I'm looking at some sort of table like this one. And I would like to know which kind of regression do I think would work best for this? Do I think that this table's showing me a linear relationship? Is it showing me a quadratic relationship? Or is it showing me an exponential relationship? And so some of you might be really good because you really know your stuff and be able to tell ooh, I know what's going on in this table here. And I can kind of mess with that and see what's going on. Some of you maybe not so much. So I'm going to kind of show you some examples here and kind of show you how you can tell how those tables are related. So first of all, I'm going to just kind of add on to this chart a little bit. So we're going to call this one the first difference. And what you're going to do, if you want to know what's going on here, is if I subtract, we're just going to look at the y values, okay? The outputs here. And if I subtract all the outputs, like the corresponding outputs, and I get the same number, then that's going to be a linear function, a linear model is what we want to say. So this first difference, I'm just going to take my y values. 3 minus 0 is 3. 12 minus 3 is 9. 27 minus 12 is 15. 48 minus 27 looks like 21. So I subtracted the second y value minus the first y value. Second y value minus the first y value. Second y value minus the first y value. And then I just wrote those differences here. If those turned out to all be the same number, then this would be a linear model. All right, this would be something linear is going on. We have a constant rate of change. It's changing by the same number every single time. As you can see, that didn't happen. What I can do is I can look at the second difference. So in the second difference, if I subtract the new ones and I get the same thing, that's going to actually be a quadratic function. Quadratic model that we want to use. And look how cool this is, because you can see it here. Obviously, we had nothing up here because we subtracted. So 9 minus 3 is going to give me 6. 15 minus 9 is going to give me 6. 21 minus 15 is going to give me 6. I probably should have done another one so it wasn't demonic. But you can see that when I took the second difference, when I subtracted again, they all turn out to be the same. So really, if I wanted to make a regression for this and like Desmos like we did on Friday, this would be a quadratic regression. this is actually a parabola. We only see half of it. So maybe you couldn't tell that it was parabolic because we don't see the symmetry, but it's going to be because the second difference gave us that same number. And so that's going to show us what's going on. Let me show you an example of the other ones, what those might look like, right? So, for example, let's say we had a table of values. And let's say it went -5, -11, -17, -23, -29, like that. All right, so again, maybe I can't tell, ooh, is this quadratic? Is this exponential? Is this linear? Not sure. So I can start with doing that first difference. And what's interesting here, so -11 minus -5 is going to be -6. -17 minus -11, bam, bam, is going to be -6. -23 minus -17 is going to be -6. -29 minus -23 is also -6. See, I learned my lesson. If our first difference turns out to all be the same, or really, really close, I suppose, then this is going to be a linear model. We have a constant rate of change this time. And actually, that's what we've always done when we saw how was the y value changing. Well, in this case, it was just subtracting 6 each time. And we can easily see that first difference, and usually that's why linear ones were like, oh, I know it's linear because it totally, I can tell it's linear. Because we just kind of do that automatically now that we've done it so much. So the first difference, if it's linear, usually that's pretty easy. If it's quadratic, you got to take that second guess. And sometimes quadratics look like they're exponential. If it's exponential, they are not related. You can't subtract to get there. So let me show you an example of one of those. Spoiler alert. Let's say you had 0, 4. Oh, x and y, that was weird. There we go. 0, 4, 1, 16. All right, cool. Actually, I'm not sure. We'll check this one. I thought it was exponential at first, but I might have wrote that down wrong. So let's check together. So let's check the first difference. So 16 minus 4 is going to be 12. 36 minus 16 is going to be 20. 64 minus 36, what's that? 28. 100 minus 64 is 36. Well, not sure if you see it. Oh, maybe you do. But if we check the second difference, 20 minus 12 is going to be 8. 28 minus 20 is going to be 8. And 36 minus 28 is going to be 8. So this one is actually quadratic. It's a parabola. So, obviously not what I wanted to show you. But that's okay. I'll just make one up. So, that's cool. We found out it was quadratic. So we can do a quadratic regression. But I would like to show you an exponential one. And so I can do that here. I'll just go 0, 1, 1, 3, 2, 9, 3, 27, and 4, 81. So let's check out, spoiler alert, and it's probably going to be exponential this time because I just did it in my head. But let me show you what it's going to look like. So let's say I'm not sure. I'm going to do my first difference. And 3 minus 1 is 2. 9 minus 3 is 6. 27 minus 9 is 18. And 81 minus 27, let's see, that would be 54, 70, 81. Yeah, we're good. So obviously not the same. So then we check the second difference, right? 6 minus 2 is 4. 18 minus 6 is 12. 54 minus 18 is 36. So you can see, still not the same. And so you're like, oh, I don't know where to go with this. So if it's exponential, it's not going to be the first difference. It's not going to be the second difference. You might think, oh, I'll do the third difference. Not that either. If it's exponential, it's not the difference at all. We want to look at the ratios. The ratios of the y values. We're dividing if it's exponential. Remember we talked about how when it was exponential, we're multiplying by that number again and again and again and again. So if we take a look to figure out the table, if it's a exponential, I'm going to just divide instead. So 3 over 1 is 3. 9 over 3 is 3. 27 divided by 3 is 3. 81 divided by 27 is 3. So if it's exponential, it's not going to be subtract once or subtract twice. It's going to be ratios. We're going to actually divide those. And so typically, the easiest thing to do, now obviously there's some functions you guys don't even know about. So it doesn't have to be one of these three. But if you're not sure, I would check the differences first. So first difference, is it linear? Second difference, is it quadratic? And those don't work, try dividing. See if you can get those to work. If it does, then it's exponential like this one. So that's kind of a cool thing that you can see to figure out what's going on in the three. If you're not sure, like I said, quadratics and exponentials look very similar. So that sometimes they can be a little tricky. So just be careful with those. All right? Cool. I got some homework for you guys to try. Go ahead and give it a shot. And I'll check you out later.